Hi everyone, this video is about Big Data Programming Lab Assignment 1. In this lab, we are going to perform 3 tasks. One is using Hadoop MapReduce algorithm for finding Facebook common friends, and the other task is like using a same uh, Hadoop MapReduce for counting and summing. And other task is we'll be using one of the data sets and we perform Hive queries and Solar queries on the data set. Let me show you the first task. So we are using here Cloudera to perform our Hadoop MapReduce algorithms. My first task is finding a mutual friends in a Facebook. So we know that we have a lot of common friends for one user. So we see our mutual friends when we visit a user. I'll show you the logic behind it. So this is how, let me explain you. See, here we take list of friends, like here A is a user, B is a user, C is a user, like D, E, and A is having a B, C, D or friends of A, C, D or friends of B. Similarly, C has some friends, D has, and E has some friends. Now when what will be the final result from our algorithm? So it will be like when you take AB, so we see CD are the common friends for AB. When you take AC, BD are the common friends. When you see AD, BC, so AD, so BC is the common for AD. So B and C are the friends. So for these both AD are the common friends. Similarly, we get the list of all common friends from our algorithm. So this is our mapper function. So we are running our program, our algorithm in IntelliJ in Cloudera. So in our mapper function, we have extended our mapper function to a map reduce space that implements a long iterable text. So we are passing text variables like values, keys and values. So it will take long variable key value and text value, and it will collect the key value. Map will produce the output as a key value. Then we are storing our string line. We are using string user friends array, user string as a friend array, string attempt key value. Everything we are using as a string here, and we are initializing the tokens here for key value pairs. And because we have to iterate, we have a n number of users here, so we have to iterate our key value pairs. So in our while loop, we have taken in tokens that has more tokens. So with our for line, and it goes by the line and user friends array, it will use a split function here to find the input from the friend list, and it uses the user friends array and friends array, like user friends of friends array. Then we iterate friends list, creating key value pairs with input. This happens in a map function. So it will read the user, it will take user as a key and their friends as a values. When we come to the friends uh, reducer function, similarly we have Hadoop imports here uh, for reducer. Then in our reducer, similarly we extend our map reduce space, implements the text reducer, and we have here our iterator operator. It will take reducer will take an input from the map function, and it will build the shuffle and sort and reducer functions. It will read the values and pairs into an array. So when you take a value, like when you are seeing a common friends for two people, that will list the list that will display the list of friends. So if you see here the build list, so you are giving a friend 1 and list 1, so for friend 2 and list 2, so it will equals the for the both of friends. If you're seeing as I've shown you earlier, if you want to find friends for a b, so it has to see the common friends by from this if condition, like friend 1 equals friend 2, then it will outlist the friends. When we come, so this is our main function here. So in we are running our we are configuring our job run here. So we are setting set map conf with set mapper class and set reducer class to call our map class and reducer class. And we are also configuring the setmap output key class and setmap output value class, and also we are also giving file input format and file output format here to write our output, to read our input and output file. And then so let me show you the input format here. So this is our input file. So I have given input as like A has BCD as a friends, B has ACD or friend. So I've given I've taken list of 5 users A to E. So let me show you when I run this. When I run my program, it will show the output. So here is my output file is generated. So when we look at the output, so I can say friend A and friend B has these two are, so A B are the key here. No, to say friend A and friend B has CD as a common friend. For friend A, friend C, they have a BD as a common friends. For friend A and friend D, they have BC as a common friends. So here I can segregate it as AB as the keys and CD of the values. So this is our final output for our Facebook common friends finding with map reduce algorithm. Let's go to our second use case, like counting and summing. So counting and summing is nothing but we are using our map reduce algorithm for a counting and summing for with multiple of documents. So our use case says we have in multiple documents, and each document we have a set of terms, lines, multiple text we'll have, but what we have to perform is we have to calculate the number of occurrences of each term in all documents, and we have to perform a sum on it. So let me show you. So I have taken, so let me show you the input formats here. So I have taken two documents which has a text and numbers similarly in the same document. So when I run my program, it should show me the count of each occurrence of each word, and it has to sum the occurrences. So for example, if she in my document, it is occurrence by 1, and in document 2 it is 1, so it has to sum the both and show me like she should be as a 2, account should be a 2. So similarly guys, we have I have using the map reduce algorithm here. So in my map function, so in my map function, it will read the each value. It will take the key object, key as an object and passing a text as a value, and it will have again initialize a tokenizer here to take the uh, text values here and iterate it one. Every time it reads a word, it will add it will uh, update the count here. Then in my sum reducer, it will get the output from this map function, and it will perform the sum operations on the number of words it has, from the number of count. So this is our main function here. So we are also given a file input format and file output format. Let me run this and show you guys. So I'll perform the count. So our algorithm is implemented and here is the output. So I can tell you, so if we see in my first document, I have one here and I have another one here. So after fetching the data from both these documents, it should show me the count. One is appearing twice, so it is counting from the both the documents. 1 plus 1, it is adding, so our summing is happening here. One counting is happening and at the same time summing is happening. Then similarly 2, 3, and for every Friday is occurrences of in the document 1, it has a 1, in document 2 it has another Friday, so it is summing up the both. So we have performed our second use case, guys. Let's go to our third use case. Let me show you my third use case. Since I have closed my Cloudera terminal, so I would like to show you in my report as I have performed Hive and Solar use cases. So this is our I have considered superhero data set here, so which has for to perform Hive and Solar queries. Let me show. First we are taking superheroes dataset and superpower dataset to perform the queries, guys. So I have just loading the datasets into my Cloudera. I have just in Hive I have just loaded uh, from my local input to table superpowers, so it is just showing me the success message like table is loaded. mm, then I have created a table for the above datasets. Then for the created above table, I'm performing this 10 queries. So my first query is like displays the name and eye color of the superheroes whose weight is greater than 50 and female. So my query is like select name, eye color from superheroes. So my first query is select name, eye color from superheroes where I'm giving with a where clause like gender. I've given a condition like gender should be a female and it should have a weight that is greater than 50. When I run this query, it will show me the name. I mean, with the name of a gender, the girls' names, and with their gender and their eye color. So that is my first query, and my second query displays the race and average height of superheroes whose skin color is green, and I'm grouping them on the basis of race and name. My third query is it is displays the name, height, and weight of superheroes, and I'm sorting it by height and limited to 10. So limited to a top 10, like I'm displaying. So my fourth query is like I'm displaying the name, hair color of superheroes who are bad and female, and I'm grouping on the basis of the name and hair color of female list. Similarly, query 5, it displays the hero names from superpowers and gender, race from superheroes table, and I'm basically performing here joining them on names column, and who belongs to a human race and female. And here I'm also performing another joining on basis of the names columns who are omniscient and sorted on basis of height and limited 10. And another query is like I'm displaying everything that belongs to a superhero named Amazo from the two tables which we have just joined, superheroes and superpowers table. And another one where I'm displaying a distinct eye color from superheroes. And next query is like displaying the name of superheroes which has a duplicate values, and displays the name, gender, publisher, who are bad and male, and published by their Marvel Comics or DC Comics. So these are the 10 queries that we have performed using Hive use case on the taken dataset. Now with on the same dataset, let's see Solar queries. So here below are commands used for Solar for creating the table, and I mean for the configurations of Solar, like in creating a directory and collection. So once we load the data into Solar, so we perform these queries like I'm giving I'm selecting from the table, like giving a condition for bad and gender, alignment as a bad and gender as a female. I'm performing the AND operation here, so it should display me the both where it matches the bad and gender as a female. So this is my output, guys. Similarly with the field's name, alignment, height, weight whose name matches with man using a regular expression, I'm just giving a name and man. It should display a man and age. Then we have performed range query on height. This query is to show the hair color which has a red uh, in the whole table. Well, this query is to show the eye color who has white and skin color as a gold. We are performing the another, and uh, this color is differentiating from the race and eye color. We are performing multiple operation like and or with the gender and weight. And similarly we are also doing our race and name with using a regular expressions. Another query we are using proximity search, and we have also performed fuzzy search, which is like fuzzy search is nothing but it looks for the similar name. When you give a query to look for a book, it will also look for book, cook, the similar words, and it will display you the same similar words. So the other query is like we are giving a hair color and a race. So these are the 10 queries we have performed on our data set using Solar. Thank you.